Now that we understood what all are the different cases that we calculate time complexity and space complexity and different representations that we have for the same analysis, let's just try to understand the different rules that we have for time complexity calculation. At this point of time, don't worry about all these statements that I have here, even though I will try to give the best example possible at this point of time in this video. Later on I will try to give some more examples in live, and I will also try to calculate the time complexity involved in that particular implementation as well. So at this point of time, try to understand the statement and try to understand the examples that I am giving. Later on we will try to write some pseudocodes and we will try to calculate the different time complexities we will get. Okay, so the very first rule that we have for time complexity calculation is basically we will try to sum the time consumed by each and every line of code. What do I mean by that is, let's just assume that we are writing one function called add. This function will basically take an array, and in that function we will try to calculate the sum of the values we have in the array and we will try to return it. So as part of this implementation, let's just assume I have written 3 lines of code. If I want to calculate the time complexity of this add function, what exactly we will do is we will try to sum up the time consumed by each and every line of code. What do I mean by that is, for example, the very first line of code that I have written in this function, let's just assume it is going to take 3 units of time, and the second line will take 1 unit of time, and the fourth line will take 1 unit of time. As part of the time complexity of this add function, we will try to sum up the time consumed by each and every line of code. As a result, the time complexity will be 3 plus 1 plus 1, which is nothing but 5. Anything that we see like 5 or something like that, right, we will say it is going to take constant amount of time. Anything that you see in terms of a number, right, we will say it is going to take constant amount of time. Okay, so that is the first statement. What is that? We will basically sum up the time consumed by each and every line of code. And the second statement is basically declarations, assignments, and comparisons or any other mathematical operations that we will do will basically take the constant amount of time. For example, let's just try to understand. I am trying to write one function called compare. This compare function will basically take an array of values and is doing some operation in that function, and it is returning some value. As part of this implementation, what I have done is I have basically defined 2 variables, namely a, b, c, and at some point of time in the implementation I am doing some comparisons. A is greater than b, a is greater than the value at 0th index. All these comparison operations and assignment operations also I am doing like this. So if you see any of the assignment operations or comparison operation, for that matter any of the assignments, declarations, any of the mathematical operations that you see, right, they basically take the constant amount of time. That means whatever the variable a declaration that we have done, it will take constant amount of time. B also takes constant amount of time. Assigning 1 to C will also take constant amount of time. Comparing if A is greater than B also takes constant amount of time. And any of the logical operations A and B that we do, it is also going to take constant amount of time only. So any of the declarations, assignments, comparisons, any arithmetic operations that you see, basically they take the constant amount of time only. So that is the second point that you have to remember. And the third point is, whenever we are trying to use some internal function as part of some line of code in our function implementation, right, if we want to calculate the time complexity of the function that we are writing, we have to assign we have to calculate the time complexity that is involved in that particular function as well. What do I mean by that is, let's just assume that I am writing one function called a. Okay, this will basically take the array of values. Internally, whatever the first line that we have, we are initializing a variable a with 1, and we are initializing one more variable b with the value true. And as part of this next line of code, let's just assume that I am trying to call a function called binary search. Okay, and this function is something that I have already implemented as part of the previous implementation. Now, if I want to calculate the time complexity involved in this function execution A, right? At this point of time, don't worry how we get the binary search as time complexity as log n. Basically, the binary search will take a time complexity of log n for executing. Now, as this function is being called inside the function A, we need to sum this value also as part of the time complexity calculation of A. What do I mean by that is, since it is a variable assignment, it is going to take 1 unit of time, and B assignment also is going to take 1 unit of time, and binary search is going to take log n units of time, right? As a result, the overall time complexity of function A will be 1 plus 1 plus log n. Okay, this is nothing but log n plus 2. Whenever we see a lower order terms or constants or anything, right, basically we will neglect that. So we will say the time complexity of A will be log n. So the overall view of this third rule is basically whenever we are calling a separate function that we have already implemented, right, we have to take its time complexity also in the implementation of the function that we are calling that function in. So that is the third rule. And the fourth rule is basically whenever we are using iterative statements, right, the amount of time taken by the iterative statement will be equal to the number of times it is running. What do I mean by that is, basically iterative statements are nothing but the loop statements. For loop, while loop, do while loop, whatever the loop statements that we have in each and every programming language. If we want to calculate the time complexity of that particular loop statement, it is equal to the number of times it is running. For example, let's just assume that we have written a function called b and it is taking an array. Internally, we are running a for loop starting from 0 till the length of the array. Okay. Now, if I want to calculate the time complexity of this for loop, the time complexity will be equal to the number of times this for loop is running. Here, the for loop is running, the number of times is equal to the size of the array, right? That's why the time complexity of this for loop will be the size of the array. For example, if we have gotten 2 values in the array, time complexity of our function will be 2. If we have gotten 10, the time complexity will be 10. If we want to generalize for the size of n, we will say the time complexity of this for loop will be n. Okay. So ultimately, if we want to talk about the time consumed by the iterative statements, we will say the time consumed by the iterative statements will be equal to the number of times this iterative statement is running. So that is the fourth rule. And the fifth and final rule is basically neglect the lower order terms. So at this point of time, don't worry about this neglect the lower order terms, but let me just give a small example. Let's just assume that whatever the previous rules that we had for calculating the time complexity, using that by summing up all the lines of execution, let's just assume that the mathematical expression that we have reached to is, let's just say 5n square plus 4n plus, let's just say 10. Okay. In this case, what we will do is we will neglect all the lower order terms and all the constants associated to the highest order term. So when we say the time complexity of the particular algorithm, that's whose time complexity analysis will lead to this will be order of n square. So as part of the time complexity analysis, we will try to neglect all the lower order terms. So you don't worry at this point of time why we will see an expression something like this. When we try to give examples later in the next section, I will try to give one example which will basically explain this neglecting the lower order terms as well. Okay, so those are the different rules that we will be following for time complexity calculation. So the first rule is sum the time consumed by each and every line of code. And the second rule is all the declarations, assignments and comparisons will take only constant amount of time for execution. And whenever we are calling an already implemented function in a separate function implementation, we have to consider the time complexity involved in the called function separately. Okay, and the time consumed by the iterative statements will be equal to the number of times they are iterating, and the final rule that we have is neglect the lower order terms. Okay, so those all are the rules that we have for time complexity calculation. In the next video, let's get started with the different examples and most commonly seen time complexity analysis expressions.